be discussing the Pnictogen family in this video. So without further ado, let's start. First, let's discuss the properties of the Pnictogen family. They have many properties, and some of them include that they're all solid at room temperature, with the only exception being nitrogen, which is a gas. Its name comes from the word pniktes, which is Greek for choke. The reason this is because of the property of molecular nitrogen in the absence of oxygen. Also, the Pnictogen family all have 5 electrons in their outer shells, and their density sharply rises as you go down in the group. Many of the group members also are highly reactive to oxygen and will form molecules such as phosphorus oxide and others, such as antimony oxide. Concerning ionic bonding, the Pnictogen family actually uses a method called covalent bonding, which involves the element sharing the electron with another molecule. Also, concerning the valence electrons, there are 5 in the outer shells, as described earlier. 3 of them are located in the unpaired p shell, and 2 of them are located in the unpaired s shell. That makes their bonding patterns have triple and double bonds with other elements. Pnictogens can also react with hydrogen atoms to form Pnictogen hydrides such as ammonia. Ammonia solutions can be used to clean, bleach, and deodorize. They can be sold as oils and fats in the chemical industry. The ammonia sold for household use is a dilute water solution of ammonia in which aluminum hydroxide is the active cleaning agent. Nitrogen is the first member of this family and has existed for a very long time, but humans were only able to recognize it in the 1770s. The first 2 people to isolate this in an experiment were Henry Cavendish and Joseph Priestley, who were able to isolate nitrogen gas from other types of gas, but they did not realize that this discovery was nitrogen. 2 years later, in 1772, Daniel Rutherford published a paper that isolated this element for the very first time. Properties of nitrogen. Nitrogen is the 11th element in terms of atomic number and has N as the atomic symbol. It is found in abundance in our atmosphere, making about 78% of it. About 3.2% of the human body is made of nitrogen. It has roles in the human body such as making amino acids and helps plant grow in the chemical industry. It can be used to make fertilizers, nitric acid, nylon, dyes, and some part of explosives. Also, it can be used in liquid nitrogen, which can be used to treat cancer cells. The first person to discover phosphorus was Hein Brandt in 1669. He made the element by evaporating urine and seeing it condense in water, but thought it was initially the philosopher's stone, but later knew that it was a new element. Phosphorus is the 15th element in the periodic table and has a symbol of pH. It is found in abundance in Morocco, which has the largest proven reserves of phosphorus with 50 billion tons. It can be used to make fireworks, in computable objects, is prime component in insecticide, its application in farming and fertilizer industry is enormous. It makes about 85% of people's bone mass, and it has an abundance in Earth's crust of 0.099%. Arsenic has been recorded for thousands of years, including to as far back as ancient Egypt and scrolls in the ancient Chinese, but the first person to discover and name this element was Albert Magnus in the 1200s. Because of arsenic's unique semi-metallic properties, it can be used in semiconductor technology, assuming that the arsenic is high purity, of course. Additions of 2% of arsenic to lead can assist in the manufacturing of lead shot to improve its sphericity. Bismuth was discovered as back as the 1400s by an alchemist in Europe. Within a few decades of its discovery, it has become a very integral part of medieval Europe and has been used in as far as Mesoamerica in the Incas in the 1600s. The name of the element comes from Byzantium, a distortion of wasse-masse, which means white blob in German. Pure bismuth is a brittle white metal with a pinkish whitish color. Bismuth is sometimes mixed with other metals such as tin, iron, lead, or cadmium to form low-melting alloys. These low-melting alloys are used in such things as automatic fire detection systems and fire sprinkler systems. Its abundance in the Earth's crust is 0.085%, which is relatively uncommon for metals, especially compared to iron and copper, which can be found in abundance in Earth's crust. The 5th member of the Pnictogen family is antimony. Antimony is 51st in the element in the periodic table and has the symbol Sb. Antimony is a silverish, lustrous gray metalloid with the Mohs scale hardness of 3, which is too soft to make hard objects. It has poor durability but can react with oxygen to form antimony trioxide, which can be useful in some instances. Antimony was discovered as far as 1600 BCE and is relatively common around the world. The first person to ever isolate this in an official paper, however, was Nicolas Lemery, a chemist from France, who published it in a scientific discovery. Properties of antimony. Antimony is a highly brittle white metal with blue stains and has a semi-metallic feel to it. Antimony can be made into alloys so that it can be made into batteries, low-friction metals, cable seasoning, and other products. These compounds can be used to make fireproof materials, glass, pottery, ceramic, emeralds, and paints. Its abundance is 0.00002% in the Earth's crust, which makes it incredibly uncommon for a metal. The last element of this group is Moscovium. Moscovium was discovered in 2003 by combining calcium-48 atoms and americanium-243 atoms. The discoverer was the head of the research team, Russian physicist Yuri Oganessian. As it seems, the name is based off Moscow, the place where it was discovered. The first proposed name was actually Langavanium. Moscovium is a super heavy synthetic element that has the number 115 in the periodic table using the symbol MC, or previously UUP. Because of its highly heavy and reactive element, no one knows its abundance in nature or if it has any biological role. Unfortunately, it has no use in application today, but for research purposes. Its boiling and melting point are a mystery as well. Because for a very long time this element was not known, it had the symbol UUP, but after its discovery and official naming in 2003, its name has been and symbol has been changed to MC